8.6, regular annuities. This time the present value. Okay. So the present value, just like with compound interest, is the amount of money you want to know at the beginning, right? So the present value of an annuity is the value at the beginning of the term of the annuity. So it represents the sum of all the present values of each payment. So when you think of it this way, there's two situations. One where you're investing money. The question you're asking is, well, how much money should you invest now so that you can receive equal payments, regular payments of $5,000 a year later? And so the answer to this question would require to calculate the present value of the annuity. If you're borrowing money instead, so situation number 2, when you have a loan, you're making payments of $450 a month on a $20,000 car loan for 5 years at 4.3% per year interest. The present value of the annuity is the initial amount of the loan. So the present value is $20,000. Okay. So in other words, you borrow money. How much money do you have to pay back in your regular payments? Okay. So another common situation is when people retire, they would like to have payments made to them on a regular basis so that they can replace the lost income. So they need to know how much they need to invest now in order to receive payments at regular intervals. So this is how pension plans work, or trust funds, or even your education amounts. So or even things like cash for life lotteries, where you're getting regular payments throughout a period of time. So the way to calculate present value, it's similar to the future value. It's PV instead of the future value. Regular payments are still there. The square bracket changes a little bit, but you're still dividing by I. So you're going to use this formula here to calculate present value. And of course, it doesn't really concern itself so much how to find this formula, but you could rearrange. We're just going to use the formula presented as is. Okay. So example number 1, suppose you determined that you need $5,000 each year for 4 years to pay your post-secondary tuition. Okay, so your regular payment is $5,000 every year. How much money do you need to invest today into an account that pays 9% compounded annually? So what's that amount that you need today? That's our present value. The regular payment that you want to receive is $5,000 a year. Okay, the interest rate is 9%, so 0.09 divided by 1, because it's an annual interest rate, so it's just 0.09. And the number of payments, the number of periods are going to be 4 times once per year, because it's 4 years times once per year, so it's just 4 years. So your present value calculation is going to look like this. $5,000 regular payment, 1 minus 1 plus 0.9, so 1 plus I, raised to the exponent negative n, so negative 4. Close the square bracket. Divide by I, which is 0.09. Okay. So be careful with the calculator. Make sure you follow the order of operations correctly. So if I calculate this, everything inside the square bracket, do 1 plus 0.9, it's 1.9 to the exponent negative 4. And then you do 1 minus whatever answer you get here. And the result should be 0.29157479. Now you don't want to be rounding it, otherwise you change the accuracy of your answer. So keep that answer in your calculator, store it in memory, and you multiply that number by 5,000 and divide by 0.09. You should get a regular payment of $16,198. Sorry, a present value of $16,198.60. Okay. So what does this mean? Well, okay, remember, $5,000 each year for 4 years. That's $20,000, right? 5,000 times 4 is $20,000. But with interest, I only need to save $16,000 today. So if I save $16,000 today, then when I receive my regular payment, this money gets invested still throughout the time as I'm getting those regular payments. So I can afford to draw $5,000 each year for 4 years so that I can pay for post-secondary tuition, college or university tuition. So this is how present value works. Okay, so example number 2. Jordan sets up an annuity to help his son pay living expenses over the next 5 years. The annuity will pay $50 per month. The first payment will be made 1 month from now. The annuity earns 7.75% per year compounded monthly. So how much money did Jordan put in the annuity? So present value, again, is what we're looking for. So how much money does Jordan need to invest today so that they can get regular payments of $50 a month, right? That's the regular payment. This $50 per month is the regular payment, 50. My interest rate is 7.75%. So as a decimal, that's 0.0775. So divide that percentage by 100. And don't forget, it's a compounded monthly. So I have to divide that by 12. Okay. And the number of compounding periods. So over a 5-year period, there are 12 compounding periods per year. So 5 times 12 is 60 total periods. All right. So now that we have the numbers, we're ready to go. Find the present value. So PV equals 50 is my regular payment. 1 minus 1 plus 0.0775 over 12 to the exponent negative 60. Don't forget present value has a negative exponent. And that's divided by I, so 0.0775 over 12. Notice how I'm not simplifying these fractions. It's a good idea to always calculate them like this in the calculator. That way you capture all the decimal places. Don't do any rounding. Okay, so you do your 1 plus 0.0775 over 12. So basically divide these two and then add 1 to it. Take whatever answer you get, take it to the exponent negative 60. And whatever answer you get from that, you subtract that from 1, and then multiply that answer by 50, and then divide by this fraction over here. Okay, so practice this on your calculator. You should get $2,480.53 for your present value. Okay, so I'm going to make a note here. When you're doing these calculations, use brackets on the calculator. Otherwise, you're going to run into trouble. Okay, concluding statement, Jordan put $2,480.53 into the annuity. Okay. Part B, how much interest will the annuity earn over its term? Okay, so if you have a regular payment times the number of terms, you'd get the future value, how much money you're going to be earning. So $50 per month times 60 months gives you a future value of $3,000. Okay, so there's some interest, right? So you invested $2,480.53 today so that you can make these regular payments of $50 a month later on. So once you made those regular payments, it turns out that the total is $3,000. So the interest you make is the difference between this $3,000 and the $2,480.53 you originally invested. So the interest is equal to the future value minus the present value. So $3,000 in the future minus the $2,480.53 you invested today. Your investment will grow by $519.47. So therefore, the interest earned is $519.47. Okay, let's look at another example. My last one here. So Robin bought a bicycle for $1,500. She arranged to make payments to the store at the end of every month for 1 year. The store is charging 11% interest compounded monthly. How much is each monthly payment? So she bought a bike. This is a loan situation, right? So she bought a bike. She had to borrow money to buy that bike. Okay, and so the store giving her the bike. Basically, the store is giving her $1,500, and she has to pay the store back monthly payments for 1 year. Okay, so the present value is $1,500. That's the value of the bike. That's how much money she borrowed from the store to pay for that bike. So what's the regular payment? That's the question. Well, how much does she have to pay every month so that she can pay that loan back within 1 year? Okay, so the interest being charged is 11%. Okay, they have to charge interest because that's a lost opportunity cost of money, right? Interest is the cost of borrowing money. If the store can't make any extra money, then why would they loan the bike out in the first place? Why would they make the loan for the amount of money to buy the bike in the first place? So you have to have interest. So 11%, compounded monthly, so divide by 12. Okay, so keep that as a fraction, 0.11 divided by 12. 0.11 comes from taking the 11% 1% and dividing it by 100. You have to convert it to a decimal. Okay. N is 1 times 12, so 1 year times 12 payments, monthly payments, so it's 12. Okay, and so there you go. Use your present value formula to find the regular payment. So we're going to do a little bit of manipulation of the formula here. So PV equals R, 1 minus 1 plus I to the power of negative n divided by I. So my present value is 1,500. That's equal to my regular payment R. 1 minus 1 plus 0.11 over 12 to the power of negative 12. Close the square bracket divided by 0.11 over 12. Okay, so how do I find R? Well, let's multiply first both sides by 0.11 over 12. And doing that effectively cancels these two terms. So on the left side, I have 0.11 over 12 times 1,500. That's equal to R times the square bracket, 1 minus 1 plus 0.11 over 12 to the power of negative 12. Okay. Now what happens if I divide by everything in the square bracket? Okay. On both sides of the equation, so I can balance it out. Well, if I do that, then this square bracket cancels with this, and I'm left with R. So I'm going to say here, R is equal to 0.11 over 12 times 1,500, okay, divided by everything in the square bracket. So that's 1 minus 1 plus 0.11 over 12 to the power of negative 12. Okay, so basically this whatever is here goes here. Okay, now doing this in the calculator is a little bit, you can be very vigilant, be careful, use your brackets, bedmass rules. What you should end up having is R equals, so all of this should turn out to be 13.75 divided by, and all of this will be 0.103716843. Don't round, okay? Keep as many decimals as possible. Only round your final answer to the nearest cent. So $132.57 is the regular payment that she must make so that she can pay back that $1,500 bike in 1 year. Now, how much interest does Robin end up paying? Well, the future value is equal to the regular payment times the number of payments. So if she's making $132.57 payment times 12 payments, that's a future value of $1,590.84. So she's paying more than the actual cost of the bike. That's the price. The interest is the price you pay for borrowing money to pay for that bike. So the interest equals A, the A minus P. So the amount of money that she borrowed to buy the bike, $1,500, minus the amount of money that she had to pay back, $1,590.84. So that difference is the difference of $90.84. That's the amount of money she has to pay. I should reverse these, sorry. The future amount of the money is $1,590.84 minus the money she borrowed, $1,500, is $90.84. So the amount of interest that Robin will have to pay is $90.84. So therefore, Robin has to pay $90.84 in interest. Okay, and that ends this video. There'll be some practice problems for you to work on.